Hi, this is Stelios from the Tesseract Academy. In this video, we're going to be talking about deep learning. We're not going to be taking a data scientist perspective. This is more like an overview of deep learning for the novice user. We're going to be discussing about why deep learning is so successful, some applications of deep learning, and finally, how you can use deep learning in your own business. So let's start with an overview of deep learning. And the first thing we're going to ask is why now? Okay, there are a few different reasons why deep learning has become so powerful and so popular in the last few years. Well, the reason that it's become so popular is because of the applications that we're going to see later. But the reason that deep learning right now can actually work, not just work well, but work at all, there are three main reasons behind that, right? So the first reason is that we have loads of data. Okay, so deep learning feeds on data, and now we have petabytes of data in all sorts of domains. We have lots of data in images, video, audio, text, etc. The second reason, which is very important, is that we have GPUs which are considerably cheaper. So why this is important? The underlying representation of a deep neural network is in matrices. So effectively, most of the operations that take place from a mathematical perspective are matrix multiplications. So GPUs naturally are very good in handling these kinds of operations. They can do it very fast, which means by training deep neural networks on GPUs, we can get considerable advancements in speed. Okay, so that's very important. So whereas on CPUs, training a network might have taken 3 months, let's say, you can do it on a GPU in 2 weeks. Finally, there have been some scientific advancements in terms of techniques, methods, and optimization algorithms, which allowed us, in combination with the above, to train deep neural networks to very high accuracy. So why deep learning is so popular? So the main reason deep learning is so popular is because it has achieved amazing performance in many tasks. Okay, in tasks such as machine translation, speech recognition, computer vision, reinforcement learning, natural language processing. So many things that were not possible before deep learning are now. And also in various tasks where all techniques could achieve performance X, deep learning manages to outperform these old algorithms by achieving performance X plus 10%. So let's see some example use cases, how things were done before and after deep learning. In machine translation, for example, machine translation, first of all, has a long history, right? So it's been something that's been going on since the 70s. This is before the advent of the personal computer. So in machine translation, this field went through various evolutions. Initially, the first approaches were based on linguistic rules. They were trying to find researchers back then a middle language which would allow us to maybe translate language A, let's say Russian, to this interlingua, and then this interlingua to English or some other language. And as it happened with many of the rule-based approaches in the 70s, including classic AI, this approach required lots of fine-tuning, lots of manual work to figure out this rule. It required research team comprised of many researchers and linguists who would actually come up with these rules. And finally, it didn't work that well. So a breakthrough happened in the 80s in Japan when Makoto Nago, he had basically more success creating translations through examples, okay? So instead of just coming up with rules as to how a language should be translated to some other language, he basically took ready-made translations and then he created an algorithm that could learn from these translations. So this is basically an ancestor of the approach that became popular in the 90s. Which was based on machine learning. Okay, so this is an extension of what Makoto Nago did, where instead of just trying to come up with rules, statistical machine translation, which started based on words, then it moved on to phrases, tried to use corpora in order to extract statistical relationships between words and between languages, and then use that in order to come up with a translation. So as you've noticed, the pattern throughout all these approaches is that they are very complicated, they require lots of work, and something which is also very important to state is that even when using traditional machine learning techniques in statistical machine learning translation, the researchers still had to go through the process of coming up with many features in order to make this translation work. And in practice, many of these translations didn't work that great. So if anyone remembers what Google Translate looked like, let's say 10 years ago or so, sometimes the translation would be perfect and sometimes it would be complete nonsense. So deep learning completely changed the landscape of machine translation. So there was a paper in 2014 by Yoshua Bengio's lab, who is one of the prime authorities in machine learning, that developed an architecture that used two neural networks in combination in order to translate from one language to another. And this idea, not many people at that time realized how powerful it was. And it's a very powerful idea because essentially all you need to do in order to create a translator using this technique is to simply feed one language, one sentence, let's say, on the encoder, and then feed a sentence, the same sentence in a different language to the decoder. So effectively, you just need pairs of phrases, and the network is going to learn on its own how to create a translator. So everyone realized how powerful this technique is when Google in 2016 September, they used this technique. They used the recurrent neural networks in order to create the new machine translation suite. Okay, and since then, Google has been doing more and more research in machine translation. The latest version of their network is called Transformer, and it has given us performance that's way better than anything that had come before that. Another advantage of using deep learning for that is we just need to feed the data to the network and we need to fine-tune it, but we no longer need to come up with handcrafted features. So this means that we actually get better performance at less effort from the researcher side. And this is a slide for comparison. Okay, so you can see here that on the top you have the perfect translation, which is like a theoretical, basically bound. You can see the translation, the performance in translations between humans, the neural translation, and phrase-based, which was the previous approach used by Google. So you can see that neural translation is actually presents a significant improvement over phrase-based translation, and you can see that's very close to human translation. So deep learning is actually getting us there, right? So this is a very significant improvement in the science of machine translation, and now neural machine translation has become the standard in this domain. Deep learning has also been incredibly powerful, incredibly useful in speech recognition. So on this slide, you can see the error rate on speech recognition before and after deep learning. So using the technology that had been used from the 70s to 2010, and this technology was based mainly on Gaussian mixture models and hidden Markov models, researchers had to come up with many features themselves, and at some point they hit basically a ceiling of the performance. Okay, they were stuck around somewhere around 22%. The moment that deep learning was utilized, the error just dropped at once. Okay, it's just a better technique to use for speech recognition. This is the kind of major scientific breakthrough that doesn't happen too often. When this happened, basically everyone was in awe because it was a complete paradigm shift, right? So you use a new technique which doesn't require the researchers to spend lots of time to handcraft features, and also you get better performance. So it's a win-win situation. Deep learning has also become de facto standard for applications such as object recognition in photos and all that stuff. And there are also some other cool applications relating to computer vision, such as automatic coloring, denoising, etc. Another very cool application, we're going to see this later in the presentation as well, is style transfer. So you can, for example, get an image and then you can get a painting by a famous painter, let's say Van Gogh in this case, and you can recreate, for example, an image into the style of Van Gogh. Finally, some other cool things we can do with deep learning, which were not that easy to do before. Deep neural networks are generative models. We can use deep neural networks to produce data. That's why, for example, we can do things such as automatic coloring, but this all extends to all domains, right? So this also extends to text, and that's very important because it can actually help us create chatbots which are smarter and they speak in a more natural style. One of the early applications of using deep learning for automatic text generation was with toy examples. So this is an example output from a network that had been fed Shakespeare's tragedies, and then it starts basically outputting, it starts speaking in a manner where it actually writes up a tragedy itself, right? So obviously this is a very cool application. It doesn't have, the tragedy that this network outputs doesn't make much sense because this kind of network in this example does not have the kind of memory that would allow it to understand what the plot looks like over many pages of text, but it's still a very cool example, right? It's actually one of these cool examples that anyone who is familiar with Python can start, implementing at home and play around with it. So the important thing with deep learning in terms of applications to natural language processing is that it saves us lots of work. Okay? So I mentioned many times in this presentation already that in the previous decades, before deep learning, researchers, practitioners, they had to come up with their own features. Doing natural language processing or speech recognition, any of those things, is the same for computer vision as well, requires lots of pre-processing, lots of attempts at modeling, right? This is a very time-consuming process because you could have to spend maybe days, weeks, months to do that, try out different models and then come back and revisit those features and make sure that using the right features, maybe try to come up with new ones using your imagination. So with deep learning, all this is gone, right? So you just feed it the input and you just feed it the output. So you're saying, I care about the sentiment, care about classifying something, I care about entity extraction. And then the network learns the right features on its own. So this is the very powerful idea behind deep learning. It's really a win-win situation. As long as you have enough resources and data to train this, it's just a much better approach to do deep learning in those circumstances, such as natural language processing. You get better performance and less work. Some other pretty cool things that are taking place in this area are word embeddings. So word embeddings is a technique based on shallow neural networks, but it's used in deep neural networks. It's one of those scientific breakthroughs that when it was released, everyone was amazed. So what word embeddings effectively allow us to do is they allow us to express any kind of word in a vector space, okay? Which means we translate any kind of word in a sequence of numbers, let's say 200 numbers or 300 or 100, whatever, depends on the problem. And why is this important is that when we operate in a vector space, we can perform all kinds of operations, such as additions, subtractions, multiplications, etc. So doing that, word embeddings, allows a network to learn relationships between words in a similar way to what a human would learn. So, for example, we can feed many bodies of text in the network, and then the network will understand that the distance from king to man is the same as the distance from queen to woman. And then we can also perform operations, so you can see that the distance from king to queen is the same as man to woman. And you can get from one point to another by making some simple additions or subtractions. And you can also see, like on the right-hand side, that it can also learn what's the relationship between Spain and Madrid, and Italy and Rome, and Germany and Berlin. The important thing to keep in mind is that these relationships are learned automatically. So there's not the human there actually writing rules saying, this is a relationship between Madrid and Spain, and this is like Rome and Italy, etc. The neural network learns these things automatically. And then these techniques are used in natural language processing tasks, such as machine translation. So what's the intuition behind deep learning? Why it works so well? As I explained earlier, the main benefit of deep learning is that it can come up with the useful features, with the most useful features for any given task. So the idea behind deep learning is based to a large extent on the way that our brain works, our visual system works, right? So our visual system, it's based on a hierarchy. So you have an input, let's say a human face, and then you have some parts of your brain that detect simple features such as edges and then combinations of edges, and then these are combined in higher level objects such as archetypes of human faces, which are then combined to give the final face. So as it seems, this is the way that our brain works, and when we actually mimic this process in a deep neural network, performance in tasks such as natural language processing or computer vision just improves dramatically. Obviously, this doesn't mean that we can do that for any kind of domain. There are some domains where shallow neural networks work best, or other types of machine learning models. But in these kind of domains where hierarchical features are the norm, deep learning really shines.